So today you're here for Swirl, methods and tools to visualize and analyze student retention and major mitigation patterns. Our presenters today are from the College of Liberal Arts, the Dean's Office. We have Nick Ohm, Senior Management Research Analyst, Jason Bradshaw, also Senior Management Research Analyst, and Kim Beckert, Executive Director, Academia Strategic Planning. And with that, I will turn the meeting over to Kim. Thank you.
Thank you. Welcome, everybody. Good morning. I see a lot of familiar faces, so we are happy to see all of you and unfamiliar faces as well, of course. All right, can everybody see my screen, and are we in presentation mode? Yes, thumbs up? All right. So this is a topic that we have actually presented on for many data conferences, and we take a slightly different approach each time. So today, for those of you who have joined us before, we're not going to focus a lot on what data we're using and how to get that data and things like that. We're going to talk more about some other of the data visualizations that we've been exploring to help display the data. But of course, to understand what we're talking about and why it's important to visualize this data, I am going to provide just a little bit of context before we get started. And then Nick and Jason will jump into the visualizations and go through each of those. And as was said, please feel free to pop those questions in the chat, and we can also talk if it's hard to write the question. All right, so a bit of background. As we all know, this is set at ASU, where we all are. We are a very large institution. We have a very strong mission of access, and we have an emphasis on retention, specifically first year to second year retention. So we in the colleges are, we talk a lot about how we can support our first year students and getting them to that second year and beyond, of course, to degree completion. One of the important distinguishing characteristics of ASU that's relating to Swirl is that students choose that major prior to coming to ASU. So during the application and admissions process, a student establishes and says what major they want to be. Now, of course, they can change that. And that's part of why we're talking about this today. But the thought there is that a student then comes in their first year and they are owned by a college. That college is responsible for their academic progression and success onto the second year. And from an official standpoint, beyond also, right? So everybody has a college then that is responsible for them in that first year. So now turning to our college, we are a large college within ASU. We have 19 very diverse departments, and I actually see we have some department reps here from some of those departments. We have anywhere from math majors to humanities majors, and so our college is unique in that. We are liberal arts and sciences colleges, so we serve a lot of different majors. We also have the same admissions requirements as the university. So if you are admissible to the university, you are admissible to our college, and that also plays into some of this major migration over time. In addition to paying attention to our own majors, though, English majors, math majors, we are also the largest provider of general studies courses. So what that means is engineering, business, all the other colleges, and in particular on the Tempe campus, take courses through us. They need to take their math, their English, their science, all their general studies. And so our units have this dual mindset kind of all the time, right? They have their own majors that of course we need to care about, but they also have this other service mission in terms of providing those general studies credits to the whole university. And so a few years ago, the college underwent voluntarily a self-study of the first year. We partnered with the Gardner Institute in South Carolina, and we had representatives from departments, we had college leadership, central ASU offices all participated in different groups, and this lasted almost an entire academic year. And a lot of good things came out of that, but the focus was really on how do we support our first year students, our majors in our units in the college. And one of the things that we kept hearing through that process is this anecdotal evidence that there's this swirl happening. Now, for those of you familiar with higher ed literature, swirl refers to the nonlinear progression of students through their college career. So students don't typically start at one institution, go there for 4 years, and then graduate, right? They go to different institutions, they take some credits here, they come back, they go over here, they might switch modes, online, immersion. And so Swirl in this sense, we're talking about these changing of majors, even within our own college from the first to the second year and across ASU, right? We know that students don't stay necessarily in that major that they choose. And that's not unique to the College of Liberal Arts and Sciences, that happens across ASU as well. So as a part of that, we wanted to actually see what that data looked like. And so this is, and we'll call this the original matrix. So if someone were to ask us, hey, can you show Swirl? Can you send me a copy of Swirl? This is what we would send them right now. And I'll just go through it so you know what we're talking about. So across the top there, I'm pointing, you can't see what I'm doing. Across the top here in this row, this represents all of the full-time first-year students in fall 18. And this represents what unit, if they were in the college, or what other college at ASU they started in. So if you added up this whole row here, you would get the total number of full-time first-year students that started at ASU in fall 2018. Then those units and colleges are repeated down here in this first column. And all the cells in here say where they went. So for example, in one of our humanities units, we had 82 full-time first-year students start in fall 18. 49 of them returned to this humanities unit in fall 19, 21st day data. So down this diagonal, these shaded cells, is the number of students who came back to that unit. They may have changed majors within that unit, but they were still in that unit. And then all down this column, we can see where all the other of the 82 dispersed. So 49 came back, they all dispersed somewhere else across different units or colleges, and some of them didn't come back to ASU, so they're just not enrolled. So we also have the retention rate. Now, if you slide over here, you'll see the 60% represents, that's the percentage of 49 divided by 52. So that's a percentage of people who came back to that unit. And this column down here, this is the anecdotal, this is what we were hearing. And so all these 50s and 60s percents, units were saying, okay, so we want to have an intentional first year experience. Which 50% do you want me to focus on? How do I support the students who are going to continue on in my major, but also support the ones who might not be in the right place? And so this helped support those conversations. Now, in terms of a data visualization, if you like rows and columns, it's beautiful. It's all nice and neat, and there's some shading. We've heat mapped this before, and you can tell a lot of different things, right? You can tell about 7 different conceptual things for any one unit just by looking at this sheet. One of the other pieces is this swirled in, this final column over here, where we know that students not only swirl out of your unit, but students swirl in particular to our college, because we don't have those higher admissions requirements. So it is a fact that sometimes if students are not cutting it in a college that requires higher admissions requirements, they will find a new major in our college. So you can see lots of things on here, not necessarily the best visualization. Can't really tell a lot about magnitude unless you're really paying attention to the numbers. And so that's why we've turned and why we'll present some other ways we've visualized the data. Last year, we presented a Sankey diagram, and we'll present some others today as well. This did help us in this conversation, though. So going back again contextually, this idea of Swirl and putting some numbers and data and being able to show people what was actually going on, it actually contributed to us centralizing our first year advising. And instead of having students have to walk across campus to go figure out if they want to be a math major because they're currently an English major, they can now just walk across the hall in our centralized advising. So we decided to embrace this shifting around of majors and helping students get to find their right place. But how can we make it better? What other visualizations can we explore using the tools here that are right at our fingertips within the BI suite? Before I go on, is there any just general questions about the context or what we're talking about? And I can't see everybody, so somebody will have to just start yelling if they want.
I don't see any questions in the chat.
All right. So then just to clarify, you can, of course, do this with any data that you want to use. We are focusing on the official cohorts, and institutional analysis, of course, are the stewards of these data. And so we're focusing on fall 18 to fall 2019. And so those tables are generally available in January of the next year for those of you who are familiar with retention data. So we won't go into this a lot, but that's what we're using. You can use, of course, whatever point A and whatever point B that you want. But this was important to our college, so that's why we did this. So I'm going to go ahead and turn it over to Nick, unless there's a question.
Actually, Jason's going.
Okay. Who uses this? Do the advisors, for example, use it to help them advise individual students? So great question. Our units use this. One of the things that's most helpful with that particular, where you can really see the different the numbers within the columns, is you can see where your students are going. So that's sometimes interesting for either advisors, also unit leadership, as they're thinking about how they support their students. Since we have centralized first year advising, that's really important to the dean's office because all of that now sits in the dean's office. Our unit leadership are always interested in this, and other colleges are interested in this. And we share this with other colleges also. The data aren't secret. Anybody can get the data. It's just we've already pulled it because this is something that we're particularly interested in. All right, I'm going to turn it over to Jason.
Okay, I'm going to go ahead and segue into the visualization piece. And so what you see here is just a basic Tableau pivot table of the data that we pulled from the query. And this is contrary to the larger matrix that Kim displayed earlier. This is just using, instead of using our college units, because we have 19 of those, and you'll see why when we get into the visualization piece, why we chose this sort of pared down version for the time being, where we just used our 4 divisions. We have Dean Humanities, Natural Sciences, and Social Sciences, and then all of the other colleges are represented. There is another college here that is actually broken into a couple of other sub-college. We sort of display their sort of subsets of that college separately. I've just labeled those as college 1, 2, and 3, or whatever they are. So basically you can see this is again, a pared down version of the matrix, and this is sort of what it would look like in Tableau if it were on a dashboard, obviously with some sort of gussing up, I guess you could say. But this is just a general sort of pivot that you can do pretty quickly. And then, so we're going to take this data here, and then we're going to create some visualizations from it to see how we might sort of get a nice visual display for the data. So the first thing we're going to use, I think we're going to proceed in order. We're going to proceed sort of, I think, what I consider things to be sort of the easiest to the most complicated data-wise. And so, you know, the first thing we're going to use, which people use a lot of, is a stacked bar chart. And I think most of you may have seen those or are familiar with them or have used them in the past. So here's the first display of our swirl using a stacked bar chart. And you'll see this is the FTFYS swirl, the entry, which is swirl out. So is basically taking the columns here, and then the columns are just displayed as bar charts. And then, so along the bottom row here is the actual entry college, and then within each of the bars for those entry colleges are the tracking colleges and the number of students who swirled out of that college into another college. So for example, here you see this is college 1. So of the roughly 3,000 students in college 1, 2256 remained in that college. We skip over here and we look at college 4, and then we see of the roughly 2,800 so students, roughly 320 were not retained the next fall. And then you can see, now one thing that's troubling about this visualization there is that because there are so many partitions of the data, that it makes it sort of difficult to sort of display all of the values sort of very easily, or to see all the values and see all the partitions, especially with sort of the color scheme that you might want to use. I mean, obviously, this is just a first effort. And also you can see even the relative sizes of some of the entry colleges will actually, the detail for some of the smaller colleges or divisions are hidden, so you can't really see those unless you focus on those individually. So of course, you can filter, and maybe if you wanted to look at college 5, one of the smaller colleges, you get the detail that way. But relative to a larger college, it's hard to see that data, so that gets hidden. But this is an excellent view as an initial first step, and then you can also focus on if you wanted to see, well, where did so if we want to look at students who moved to college 9, and you can find out, well, some of them came, of the students who moved to college 9, 14 came from college 1, and 16 came from college 7, Oh, sorry, I was on the wrong one. So anyway, so this is looking at the swirl out. Now, this is a one-way view only. You can't really sort of look at the row and column view together in this type of display. So what we do is we can look at it a different way by looking by focusing on the tracking where the students ended up the next fall and where their entry college was inside the bars. So in this case, all the students who swirled into college 1, this is still the students who were in college 1 in the previous fall. Then you had 107 students who came from college 4 who are now in college 1. And then you have the final bar over here on the right is actually all of the students who were not retained the next fall. And then you can see which college they came from and what the magnitudes of those were. And again, you sort of have the same issue where you've got these bars of different heights and they're partitioned in such a way that some of the partitions are very small and hard to see unless you hover over them. And so unless you're sort of filtering or focusing on one specific area, it's very difficult to see, but it's at least a good representation as a first step. So there's another way to visualize this data, which is somewhat similar, but it's a little different, but it uses some of the same partitioning, and that's called a tree map. So this is what a tree map of this data looks like. And again, I forgot to mention on the stacked bar charts, this is just using within Tableau. There's nothing special about using this. There was no customizations or anything we had to use. This is all just canned. And there's no real data transformation or reshaping you have to do. It's just the raw data. It's the raw data from the query and in the format you get from the query. I didn't build it from the pivot. I built it from the raw data. So there was nothing really to do that in that case. And it's the same with the tree map as well. The tree map is just one of the canned Tableau visualizations you can use. Now, and most people generally will customize these, and certainly once this gets published and whatever visualization, or if we use more than one, we decide to use, we'll have some customizations and some additional information. But just as a good first step, as a good sort of exploratory tool, I think this is a good way to start. So the tree map basically treats each college as its own square. If some of you are familiar with other tree map displays, and a lot of time in statistics where you're looking at things like regression trees and stuff, the trees are built from this sort of partitioning of a square, and so that's similar to what this is. It's not quite the same, but it's very similar. So for example, here's college 1. Sorry, I lost my mouse. Here's college 1, and so you can see the college 1. This is the entry college. So this is based on the entry college. So this is the college 1, and then the number of the students who stayed in college 1. And the way the tree map works is that it displays things from left to right, sort of in greater magnitude to smaller magnitude. So you can see as you move left and down, the squares get smaller and smaller and smaller. So then you can sort of see, and obviously you lose some of the labeling because the squares are so small. It's difficult to see that. But of course, again, if you wanted to filter on the detail for one of these, whoops. So here's the college 1 just by itself. And so you can see a little bit more of the detail, but you still don't have all of the labeling and everything on there. Again, the top one is the entry college, and then the bottom one tells you where they were the next fall. So again, this is the students who were remained in the college, and then the next fall, those were not retained. So you can see it goes from those who stay and then not retained is the largest chunk of students where they in the next fall, at least for this unit and at least for this college, and then the rest are sort of scattered throughout other colleges and divisions within the university. Now, there's an alternative view that you can use for these tree maps. This is a little sort of striking and almost sort of harsh view. There's a way you can organize this very easily that makes it a little bit easier to see and to sort of absorb. And it's sort of taking the entry college and then sort of creating almost this bar-like tree structure for each individual college, so that it's easier to focus on the colleges, and it's similar to sort of a stacked bar plot. But then again, if you wanted to focus on one of the colleges, let's focus on one of the smaller colleges here, like College 6. Then you see the entry college, and then this is the tracking college here. We don't have the entry college labels on here, but you can see, and then the number of students who stayed in that college, number of students who weren't retained, though, and then again, those that moved to other colleges or divisions. And then again, the tree maps are also one-way views, so you can only view, so if you wanted to do a full swirl dashboard for this, you would need one display for the swirl out, then you would need another for swirl in, where now these colleges are the tracking colleges. And I sort of changed the colors up a little bit just to make it a little bit diverse. But so does anybody have any questions on these so far? So, so basically the stacked bar charts, and really the stacked bar charts and the tree diagrams, as far as data transformation, it's just raw data from the query. There might be a little bit of manipulation that you have to do mostly at the query level before you get the data. But again, I didn't have to reshape or transform the data from wide to long or long to wide or anything that might make it a little bit more difficult to really no high-level data manipulation. For the stacked bar chart, when you have these two categorical variables with 18 or 20 or a lot of different sort of available levels in them, and the associations between those levels, between the entry and tracking, it can make those types of visualizations difficult to read, although they're very interpretable. It's just they're hard to read, and you can lose some detail without focusing on just a few. Again, there's only one way view, so if you need one visualization for the swirl out and then one for swirl in. The interpretation is fairly straightforward. There's nothing really difficult about it, again, other than just sort of navigating around them. You can, distinct color the categories with distinct colors to make them easier to sort of focus on and pick out. And then sort of the partitions within each bar are just sized according to the magnitude that they contribute to the overall total in each bar. And as far as the required skill level, it's low to moderate, depending upon how comfortable you are with whatever software you're using. Stacked bar charts are pretty standard and easy to build in Excel, and that's free to everybody. R can do a lot, R requires a little bit more programming, but it's free to everyone. And the stacked bar charts are sort of built in to the base R package, but then additional packages, which are also free, can allow you to do a bit more customization and maybe some fancier displays. And then of course Tableau, which is what we're using here, but to publish or to do anything on analytics would require you to have a separate license for it. So, and then as far as the tree maps, really the same things that we talked about with the stacked bar charts apply to the tree maps. You don't have to do a whole lot of data, no data transformation or reshaping at all. Really was raw query output with a few computed items that were sort of built into the query itself when we ran it. Again, the whole cluttering and difficult to read issue is sort of part of the whole. We have so many levels with each of those categorical variables that it can make it somewhat difficult to read, especially ones that have small magnitude associations. Then again, they're one-way views only, so you would have to have two different views depending upon what you were interested in, either swirl out or swirl in. Interpretation again is pretty easy, and then one good thing about the tree maps is that they automatically sort of order the magnitude based from largest to smallest. So if that's what you're interested in. And again, on the stacked bar charts, you can also order those any way you want. I kept an order in order of the college, but you can sort of order those any way you want. And Again, required skill level is moderate. I think they're a little bit more difficult. You can do these in Excel, but it does require a little bit more customization. It's not really a built-in Excel. You might be able to download some add-ons to Excel that might help with that, but you might have to pay for those. But it's something that you would have to sort of build a custom chart yourself. In R, there are packages that will allow you to build these, and also other things called mosaic displays, which are more for statistical and sort of studying statistical level association between the categorical variables. And then of course in Tableau, which is what we display, which is what we demoed here. Does anyone have any questions?
I'm not seeing any questions in the chat.
Okay, so I'm going to turn it over to Nick, and he's going to discuss some other visualizations that we also explored that we thought would also help us interpret and explain this data.
All right, thanks, Jason. Good morning, everyone. Let me just share my screen. I'm not ignoring you guys. My display screen's here, my camera's here, so I'll be looking this way for my presentation. Okay. Everyone can see okay, cool. So as Jason mentioned, the charts I used are a little more cumbersome, a little more difficult to build, but they do have some great value. So the first chart I made was a sunburst chart. Now, the data transformation required for a sunburst chart is a little more difficult. You do have to pivot the data. You have to know the relationships between the variables in order to eventually create calculated fields, which are part of the building this chart in Tableau. I actually built this chart in Tableau and Excel, so I'll show both versions. And then with a sunburst chart, it also only has the one-way view. So you only see the swirl out or you see a swirl in a separate chart. You can't see them simultaneously like you can in a Sankey diagram, which I'll talk about a little later. The ease of interpretation for a sunburst chart is low to moderate, but it depends actually. So if you're looking at all the colleges like we showed, all the swirl from all the colleges to all the other colleges, it is difficult to interpret. But the good thing about Tableau, you can insert a filter field in there, so you can filter for just 1, 2, or 3 entry colleges to see where those 3 colleges, where swirl outcomes comes from in those 3 colleges. And I'm actually going to have an interactive visualization as well in a second here. So the required skill level for a sunburst chart is moderate. I mean, a lot of what Jason was saying about Tableau too is you need access to Tableau. But for building this sunburst chart, you do need to know a lot of the formatting aspects, a lot of the components of Tableau that require some time and research and maybe some training in order to build some of these, to build a sunburst chart, which requires a lot of, like I said, calculated fields and different formatting aspects. There are instructional videos that help you build this, but again, if you don't know some of these capabilities of Tableau, these formatting needs of the sunburst chart, it's going to be hard to follow the instructional video. And the sunburst chart, it's a great alternative to the Sankey diagram, because I'll show you the Sankey diagram. It is vertical, so all the colleges are vertical on one side and on the other side, and it can be a real long list, whereas the sunburst chart is radial, and so you can see everything in a smaller screen essentially. But then that does lead to some cluttering if you're looking at a lot of colleges, so there are some downfalls to that as well. And just as a side note, an alternative to a sunburst chart would be like a funnel chart, but only if you're looking at one college and the swirl out from that one college. You can kind of see how it funnels from that one college to other colleges the following year. So I'm going to show you my sunburst chart. Everyone can see the sunburst chart? Yes, okay. So here is the sunburst chart. This shows you all the colleges. So this smaller circle, inner circle, is the swirl out colleges or the entry colleges. And And then the larger outer circle would be the tracking colleges, or where students went to from the entry college. You can kind of see there's a lot of noise going on here, a lot of different colors. So if you do really want to use a sunburst chart, I would recommend putting a filter on it. So if we filter for just one college, we'll do a couple colleges. You can kind of get a better idea, excuse me, get a better idea of exactly what you want to see, which is the swirling aspect. So if we look at college one, all this is part of college one. So you can kind of see college one had 3,000 entry students, and then 2,256 stayed. So there's your retention, and then not retained 416, and then all of each of these is a college they went into. So some of the smaller colleges. That is another downfall of having a lot of colleges in there, is that there's not enough color palettes in order to explicitly see the different shades of 4 different colleges. Unless you get really close, it's kind of hard to see all these. So you can even in Tableau just right click and keep only one college, and that gives you a little better idea of just that one college and the swirl out aspect of that one college. Now you can do the vice versa and flip this data so you can see the swirl in, but it's going to be a separate chart. So maybe if you have a dashboard, you can have like a swirl out sunburst chart and a swirl in sunburst chart next to each other, but you won't be able to have that simultaneous swirl in and swirl out view aspect like you can in a Sankey diagram, which I'll show you. Okay, so any questions about the sunburst chart from anybody? No? Okay. So next will be a Sankey diagram. So as Kim mentioned, last year we did a diagram using the Sankey diagram, and we use that in RStudio, which does require a little more data manipulation. I tried making a Sankey diagram in Tableau, and the data gods doing what they didn't allow me to have that ready for today. So I just have a screenshot of a Sankey diagram, but we're hoping to use the Sankey diagram like we did in R, but put that in Tableau because of the more functionality that Tableau provides, as well as being able to put that visualization through Tableau onto our analytics webpage. But a Sankey diagram, again, the data transformation is difficult. You need to understand the categorical variables between the data. It's the Sankey diagram that I started to build through Tableau. You needed to union the data, pivot the data, and then you have to create, I think there was 10 calculated fields in order just to create the different swirl variations in Tableau. But it is easier to look at. So a Sankey diagram does give you a little more room, so there's a little more spaced out in between colleges, and you do get that easy to flow view from one college to another. And in Tableau, like I showed you in the sunburst chart, you can click on certain colleges, filter certain colleges, and you can just isolate one college to see what that swirl out is, but you would also be able to see what the swirl in is on that same chart. Okay, let's see. How am I doing on time? I'm doing all right. As I alluded to already.
Sorry, and we did have one question from Mike Sharkey. He's still looking at understanding the audience for these diagrams. So are they data savvy users? Are these kind of non-tech business users?
Yeah, I believe he used the term everyday people. They are everyday people, Mike. I mean, there are some data savvy, but it's mostly our departments. Our departments ask, our college leadership ask. Like I said, one of the most appealing things is to see where are they going? What kind of conversations can we have with them, either through advising or through courses or through any of our student support mechanisms about that, about embracing that change and making sure that they're in the right place. I just had a request this week yesterday for from one of our departments because they're looking at doing some specific support structures. So they asked for a swirl for a specific group, not this larger group, but a specific group. They wanted to understand where those majors are leaving to and where they're coming from. So everyday people, but certainly some of those everyday people are also data savvy.
I was
But
going to
they wouldn't
use
create
I was,
this.
I was going to
So-
use normal people instead of everyday people, but that would make us abnormal, so I didn't use that.
But the idea is that they're not creating these. The idea is we're creating these for them to consume.
Absolutely, thanks.
And there's different versions too. So actually that reminded me, I was going to show you a version of the sunburst chart in Excel, which is a canned chart in Excel. So I didn't have to build anything with this. I still had to manipulate the data, do all the data transformation, but literally it's just a pivot chart in Excel that you can visualize as data. Now you don't get the functionality of Tableau, being able to hover and select certain colleges. But if you get the data prepared where you're only looking at 1, 2, or 3 colleges, then this will just show these 1, 2, the biggest 3 colleges or whatever you want. And the visualization will be a little easier to read. So depending on your skill level, there's different charts you can use, same types of charts, just in different programs. And I think that's kind of what we wanted to talk about today too, is just letting you know there's different ways to do the same charts as well. Okay, back to the Sankey diagram. So you do need a Tableau license if you're building that in Tableau, or if you want to build it in R, but that's requires a higher level skill set if you do want to build it in R. An alternative to Sankey diagram is a chord diagram. I don't have a picture of that, but chord diagram has your simultaneous view as well. You can see swirl in and swirl out in a radial view as opposed to the rectangular view. So it gives you a little less space to work with, but it's a little easier to read if you have a lot of colleges in there. And so this is actually our Sankey diagram from last year that we showed. Like I said, I was hoping to have a newer visualization, but it's essentially the same thing. So you have on your left column would be your entry college. And then the swirl out would go into the right column, would be your tracking college or where students were the following fall. You can see there's a lot going on in this as well. So if you limit this, it'll be a little easier to read, but this is the best visualization if you're looking at all colleges really. And the thickness of each line is how many students flow to that other college. So it gives you a little better idea of just the amount of flow from one college to another. And that's on this left side. On the right side would be if you're just looking at one college, one unit. I think this one we're looking at one unit in our natural sciences department, and where students flowed or swirled out from there from fall to fall that we were looking at, and then how many students weren't enrolled. So this is a little better visualization if you're looking at a lot more colleges. And like I said, in Tableau, the Sankey diagram would give you, Sankey diagram in Tableau would give you the option to filter easily or hover over some of these colleges and be able to track these and look at these a little easier. And okay, any questions about the Sankey diagram or any more about just these more advanced charts?
I got a question. Kind of in general, are these vizzes meant to be informational or actionable or both? Like if you had to say, what's the goal of these charts?
I would say both. I mean, it's like Kim said, we already have people requesting this specific information in order to use it. And if we have this available on our analytics site, I would say a lot of units would use this to see, hey, this is where our students are going or where they're coming, where students into our unit are coming from. So I would definitely say it is both. Yeah, absolutely.
And I think Mike, well, we focus on just 1 year, but I think what we could also do is you can do a deeper analysis with this data by looking at multiple years of swirl and then doing some comparisons, like is behavior of students swirling out from one college to the other, is it uniform over the previous years? Is there, or you can do some, and I think the actual piece would be doing some more detailed analysis on the data, such as looking at why the students are maybe moving somewhere, or maybe are there interventions that you can use to sort of figure out why they're moving, or are there patterns in the movement year over year if you're looking at different years. Again, right now we're focused on one, but our goal is to provide not only just the visualizations, but also additional information to help inform sort of the why it's also why some of it may be happening, as opposed to just it's happening like this. Does that make sense?
I'm going to stop sharing.
I think Mike went blank. We had a couple more questions, if we may. So on the chord diagram, what tool was used to create that?
Yeah, good question. So that was another one I started in Tableau as well. The chord diagram required a lot of what I was doing with the sunburst chart and what I was doing with the Sankey chart, which was a lot of data manipulation and calculated fields. But that was one I couldn't get to be as ready for presentation as I wanted to. And it was actually my preferred one to make. That's when I started making at first, but it was becoming very cumbersome and time consuming. So I would have done it in Tableau, is the short answer.
Second, additional questions. Do you survey students to find out why they changed majors? I guess that's an action for what does the everyday user do with the data?
Yeah, sorry, my connection dropped out. I had to see you come to ASU and you have an unstable connection. So if there was another question that I was silent on, I wasn't here. But to that point, and to go back to Mike's point, I would call these data, they're best for, or these visualizations are best for exploratory nature. We're not going to make any sweeping policy decisions or anything based on what we see, but it allows us to then go ask additional questions. And I think last year some questions brought up in the data conference when we presented just the Sankey was, well, have you split this by different, student characteristics? Have you looked into that? What is the analysis that can be, that can come from this? And so that's definitely something we're interested in doing. And we can do it, and the data are all there to do it. But this is more to show what's going on so that then people can decide what else they'd like to explore. So in terms of the surveying, not as a central unit, no, but certainly our advisors get information all the time about why students aren't coming back. There's Salesforce campaign data that can be mined to help explore some of the reasons why someone would change a major or not come back to ASU. So we have lots of different data sources at ASU to do that. It's not something we've engaged in at this point.
Continue to have a barrage of questions here. We have Brandon want to know, have you looked at incidence of swirl versus student persistence? So meaning, do students who change colleges retain better or worse than their peers who remain in one college?
Good question. I saw Diana's on here. I think Diana did something at the universal level. So keep in mind, this isn't an excuse, but we're interested in all those questions, but we're representing our college. So I think these are some good questions for the university and some of the university central offices to be looking at as well. And I know they have in those cases, but we have not looked at that specifically. I would open that if anybody else on the Zoom here has, they can feel free to speak. Sorry, Jason, you wanted to say something?
Jennifer Wilkin actually posted a response to Branding. She says, we have long-term work along these lines exactly, not just college switching, but major change. And she mentions that there's a web form for change of major that captures some reason for the data. Reason data, yeah.
And it looks like our poll already started, so
yeah.
I'll share what, or I guess you have all the answers there.
And I also wanted to point out that as far as the data that we, this data set was only 12,000 records, and we're only looking at basically we're only comparing two categorical variables to one another. And you saw how complicated that those visualizations became because of the magnitudes of the associations, either small or large. and how difficult visualizations can be for what I would consider a small set of data. And so you have to make a lot of decisions, even if your data is very small and you're not really comparing or trying to look at associations between two variables. There's still a lot of decisions you have to make. Basically, I think the lesson is like, no matter how big or small your data is, you always have to sort of really spend some time in the exploratory phase trying to make a decision on what makes the most sense.
You know, and contextually, we also know part of the reason we do 21st day to 21st day, though this doesn't actually get at what I'm about to say, if you have to understand contextually how a student changes a major, it's not actually clean. A lot of it depends on what date. Is that backdated to the first date of the semester? Did that student actually spend most of the semester in a major, then make it, you know, we have actual business rules and business processes that we do at the university that are different across colleges sometimes. And so when you look at this data about changing major, you have to understand what the limitations are to the data that we have available in the warehouse. The data are clean, but the interpretation, you just have to understand what might go into that to have that major change actually happen. And when students are allowed to change majors and not allowed to change majors. All of those things are important to really digging into this. Like I said, for our college, this was one of the pieces that we really looked at as, you know, in the dean's office to support this idea that we needed some centralized advising for our first year students, that there was enough movement there where we needed to change a little bit of our philosophy and say, embrace that change and figure out how to let students find that right place and help them do that so that they will stay at ASU or stay at college if it's the right decision for them. Maybe not in the same major, but they're in a better place.
I don't have any more questions in the chat, but we can certainly feel free to unmute yourself if you just let me know if you have a question. Then we'll call on you to unmute.
I also want to mention this is just immersion students. I'm not sure if I said that in the beginning, my apologies. So we can also look at it for online. Of course, this population is a little bit smaller in online, but not nothing. You can look at whatever population you want, but this was just immersion students that we were looking at.
And also I wanted to point out that in previous years, we also do a transfer swirl as well. So but we primarily focus on FTFYS, but in immersion, transfer is a smaller piece of the puzzle, but we do also occasionally look at transfer swirl for immersion students.
All right, so it looks like Sankey by a mile here.
Yeah.
Can we see that diagram again?
Who's sharing? Nick, can you go back to the Sankey?
Oh, yeah.
Oh, yep.
Nice, I like that one too.
Yeah.
Any other questions, or does the audience, are there other ways you can think about using these? Again, this is just our example of these, but I mean, I can think of a lot of ways I'd like to use a sunburst chart and, you know, some other these visualizations, maybe not to show movement so much. But we do have all of these tools now at our fingertips within the BI suite. So they're there.
A question. All of these are absolute numbers. Have you done any of this with percentages and what percent of students went from A to B?
To do the visualization using the percentages?
Not necessarily. I mean, you could work it in some ways to some visualizations, but obviously the different sizes of our colleges skews things, as you can see here in the Sankey.
Right.
Do people care about that? Are they looking at percentages, or is it pretty much all around raw numbers?
I'll let the other people answer too, but I personally like that you can see the magnitude because of that. And even within our college, right, we have not all 19 units are the same. They're so diverse in terms of discipline, but also size, right? We have thousands of students in one unit and like 50 in another. So I actually like that you can see that, because if you just blind it with percentages, but it would be easier to look at if you were just looking at percentages.
Yeah, you would definitely need to use both.
Mm-hmm. Yes. No, and the idea is once we finalize the visualization, and even on the Sankey, that both the magnitudes and the percentages will be available to will be available in the charts, in the displays.
Any more questions? Because we look like we're about at time. I wanted to thank everybody for joining us today. I hope you had a great day. I especially want to thank our presenters today, Jason, Nick, and Kim. And we will see you tomorrow for your daily data inspiration at 9 a.m. You should get an email with the agenda or check the website. Have a
Thanks, everybody.
great day.
All right, thank you.
Bye.